So this is Mr. Wise. We're talking today about the law of conservation of mass, and follow along in the notes that you have from before. The mass of the products of a chemical reaction must be the same as the mass of the reactants in that reaction. So keep in mind the reactants are what go into the equation, and the products are the new substances that are produced that come out of the equation. And the mass of the left side of the equation must be the same as the right side of the equation. In other words, whatever goes into it must be equal in mass to what comes out of it. So when you look at the image that I have here on the screen, the ones on the left can represent the reactants, and the ones on the right can represent the products. And notice that they are balanced because they're on a balance. We've been talking about equations, and equations list the atoms and the numbers of those atoms that are involved into the reaction. And so in accordance with the law of conservation of mass, the number and kind of atoms must be equal on both sides of the equation. The law of conservation of mass goes on to say that the atoms are never created in a chemical reaction. However, they do change partners. And so, the law of conservation of mass states that matter can never be created or destroyed as the result of physical and chemical changes. Now, there's an image here, and this image represents water, where we have element X, which could represent hydrogen. And so we have these smaller hydrogen atoms. And then we also have these red circles, which represent the oxygen atoms, which it says here elements Y. And the arrow would be in between the second and the third set there. Because then you see that we produce compounds of element X and Y, which just happen to look like water molecules, H2O, where you have two of the silver with one of the oxygen in there, or one of the red, and they're also in a polar molecule, much like that of water. But the point of the law of conservation of mass is that if there are elements X, and there are 16 of them, and there are element Y, and there are 8 of them on the reactant side of the equation, then there must only be 16 of element X and 8 of element Y on the product side of the equation. We didn't produce anything new. We didn't choose element Z or element W. Those things can't happen. We didn't have element Y on the left, and then all of a sudden element Y on the right disappeared and it didn't exist. So that's what it means by created or destroyed. Whatever you start with, you have to end up with. The difference is that they will rearrange themselves to form those new substances. So the compounds that we produced here, even though they contain the same elements, those compounds are new substances. You'll want to take some time to use this word bank to fill in your word bank into your notes. Now, a couple weeks ago, I had you do an assignment on counting atoms. And with counting atoms, two of the things that we use there are coefficients and subscripts. The subscripts are the smaller numbers that come after, like this little number 3 that comes after the O, and it only applies to the O. The 3 doesn't apply to the K or the N, just the O. Whereas the 2 is a coefficient, and it is a larger number that's written in front, and it applies to everything. Just like in math class, a coefficient would apply to everything that gets distributed to everything. So when we count these atoms, we would have every element would have a coefficient and a subscript. Even if there's no subscript listed, it's understood to be 1. Same thing if there's no coefficient listed, it would be understood to be 1. So for K, it would be 2 times 1 equals 2 to get a total of 2K. For N, 2 times 1 is 2N. And for O, it's 2 times 3 to get 6 for 6O. Now, we multiply coefficients and subscripts to get the total numbers that we have in that particular set. And in this example with the KNO3, it's all elements that have one letter in their chemical symbol. We know when we studied the periodic table that most of the elements have 2 letters, and that second letter, when present, is a lowercase letter. We don't have it in this particular example, but you don't really need a periodic table to do this activity. You just need to know capital letters and lowercase letters. And if there is a lowercase letter, it always gets paired with the capital letter, and the capital letter always indicates a new element that is present. So as you go through the slideshow, you can go ahead and count the atoms for practice on this particular slide. balancing equations. Now, in your notes, I just listed out the 4 steps for the balance equations. What I'm going to recommend you do is like I have done here, and that is to get a piece of paper, and you want to write out these equations, since we're doing them on the computer, to use a scrap piece of paper and write them out in order to get your answers. It's the way the worksheets work out. It's just best if you work them out and then you choose and tell me what the correct answers are to the questions that I ask. But you're going to have to balance these equations in order to get the answers. Step 1 is to write a correct equation using correct symbols and formulas. Now, that step is always going to be done for you. In other words, I'm going to give you that particular equation, but you're going to need to write out that equation. And I will show you here on the screen, if you look down at my webcam, what I did was I wrote it out just the same. Now, I didn't put in these lines, but instead I just left physical spaces because those are where coefficients could go. Step 2 is to count the numbers of atoms on both sides of the arrow. Now, I break this step down, and the first thing I do is I draw that line that is underneath. And what I'm going to do is I'm going to toggle to just my webcam here and show you as best that I can that the arrow is like the middle of the equation. And what I'm going to do is I'm going to draw a line down. Now, how long does that line need to be? Well, I have 2 elements, so I need to have space to write 2 elements. If I had an equation with 3 or 4 or 5 elements, the line might be a little bit longer. And then my first element that I have is H, so I'm going to put an H here. The next one is O. Then I'm going to recopy that list over here, H and O. Now we're starting with a fairly simple equation. They will get more complicated, but I like to start with the easy ones. Then now we're doing, remember, step 2 is to count the numbers of atoms on both sides of the equation. So when I look at the H up here, there's no coefficient. So remember, it's understood to be 1. So it's 1 times 2 to get a total of 2 hydrogen. For oxygen, there's no coefficient. So it's 1 times 2 to be 2 oxygen. Come over here to the right. Now we do each element separate. For hydrogen, for the H, there's no coefficient. So it's 1 times 2 to get 2 hydrogen. For the oxygen, it's 1 times 1 to get 1 oxygen. So that is counting the numbers of atoms on both sides of the equation. Step number 3. Oh, that's continuing on doing what I just showed you. Step 3 is to balance the numbers of atoms using coefficients. And notice that I underlined the word coefficient. Coefficient is the only thing that you can add to balance an equation. And you do that in front of the symbols and formulas. So, as I was saying, when we look at this, we say, okay, we have 2 hydrogen on the left, 2 hydrogen on the right. That's good. 2 oxygen on the left, 1 oxygen on the right. That's imbalanced. Now, we can't just simply go up here and put a coefficient, or a subscript of 2 there to balance it out, because H2O is water. If I made it H2O2, that would be hydrogen peroxide, and that's a completely different substance than what water is. So the only thing we can do is add a coefficient in order to balance this. So the process for that is to look at the smaller number, which is the O's on the right, and say, what is it that we can multiply 1 by to get 2? And the answer is 2. So I'm going to put a coefficient of 2 in front of the H2O. Now that 2 changes everything that follows it. So it's distributed to all of that. So the 2 goes to the H. So now H changes to 4. I like to just cross it off and write the new number. And then 2 times 1, I get 2 oxygen. That's what I wanted to do. Now my oxygens are balanced, but as you see, the hydrogens are not balanced. So I need to come over here and put a coefficient of 2 over here because 2 times 2 equals 4. And now I have 4 and 4, 2, and 2. These slides take you through that process. Finally, the last number is the last step that we always have in math, and that is to check to see if the numbers of all the atoms on both sides of the arrow are the same. So what I like to do is, and again, this is a simple one. It only has 2 elements on each side, so it's fairly simple to see this. But when we have, say, 4 or 5 elements on each side, it gets a little bit more complicated. So what I do is I take the coefficient and the subscript for each. So here we have the h. I take 2 times 2 is 4. Down here I have 4. 1 times 2 is 2, so I have 2 O's. On the right side, 2 times 2 is 4, so 4H. 2 times 1 is 2, so 2O. Now look down here. 4 hydrogen on the left, 4 hydrogen on the right, 2 oxygen on the left, 2 oxygen on the right. Everything looks good. Everything's balanced. Now I have a balanced equation. So now what we have is another equation, and it doesn't spell it out in the notes, but what I'm going to do is I'm going to run through the one, and then you're going to practice on your own on the next one that I have. So what I want you to do is, if you haven't already, hit pause on the video, get yourself a piece of paper, and do this along with me. Okay, so what I have done is I have written on here the equation. That's step 1, is to write an equation with correct symbols and formulas. Step 2 is to count the numbers of atoms on both sides of the equation. So remember, what I do is I'm going to draw my line underneath the arrow, because the arrow is like the middle of the equation. Then I have N, so I'm going to list N. I have H, so I'm going to list H. And I'm going to recopy that list over here on the right. N, NH. Now, for N on the left, there's no coefficient, but there's a subscript of 2. So 1 times 2 is 2. For hydrogen, or H, 1 times 2 is 2. For N on the right, there's no coefficient. There's no subscripts. Remember, it's understood to be 1. So 1 times 1 is 1. And for hydrogen, 1 times 3 is 3. So that is step 2, counting the numbers of atoms on both sides of the equation. Now I'm ready for step 3, which is to balance the equation using coefficients. So I look here, and I have 2 nitrogen on the left, 1 on the right. Well, that's an imbalance. I also have 2 hydrogen on the left and 3 hydrogen on the right. Now I'm going to go to hydrogen this time, just because it's 2 and 3. I want to explain that. So we can only use whole numbers. I can't add half of an atom of hydrogen to the left. I can't do that. So when I get these numbers 2 and 3, I have to determine what is the least common multiple of 2 and 3, which is 6. So what I'm going to do is I'm going to look at the hydrogen that's on the right and say, what do I multiply 3 by to get 6? The answer is 2. So I'm going to use a coefficient of 2 in front of the NH3. That changes my nitrogen to 2, because remember, by using a coefficient, it applies to all the elements that are in the compound. And then 2 times 3 is 6 hydrogen. That's what I wanted. But I'm not done yet. I need to come over here to this side. What do I multiply 2 by to get 6? And the answer is 3. So I'll use a coefficient of 3. And that one just applies to the hydrogen. This little plus sign right here separates the two, and so we don't carry those over when we multiply. If you'll notice, balancing the hydrogens balance the nitrogens as well. Now, we might have come up to the same answer that we got anyway if we started with the nitrogen, but I wanted to show you the 2 and the 3, that sometimes you need to increase both sides in order to get it that way. And so what we're always doing is we're looking for the least common multiple in order to do that. So what I want you to do now is, on your own, I want you to balance Al plus O2 yields Al2O3. And then we will do more practice as we move along in these lessons. Have a good day.